Hello, this is Mrs. Huntley. This is Module 1, Topic B, Scientific Notation. You should have already watched Video 6, and this is because the lesson for Video 6, the first lesson in our supplemental packet, went so long, I'm teaching half of it live in class. Now, I wanted to record a video for those of you that either were not in class or if you didn't understand it in class so that you'd have a resource. Also, for those of you that are going to be watching this in HARP, so that you don't have an excuse for, well, Mrs. Huntley didn't do this on the video, and so I'm not responsible for it. You are responsible for it, and I'm going to record this video to help you through it. So you are on page 37, or the second page of your supplemental packet. If you watched the first part of video 6, you should have the top part already filled in. And number 7 says rearrange all of the digits and decimal below to build a number with the given conditions. If needed, write these numbers on a separate piece of paper, cut them out, and rearrange them. So if you're a super visual person or tactile person and you need to actually have like tiles with numbers written on them and you can manipulate them and move them around, that's fine. You can go ahead and do that. I'm not requiring you to do that, but I'm going to do a couple of these for you so you can get the gist of what to do, and then I'm going to ask you to finish it the rest on yourself. So we have the digits 3, 0, 7, 8, and a decimal. And what they're asking us to do is manipulate the numbers or move them around to build the largest number possible. So of course we want to start with the largest number value. So we're going to start with an 8. The next largest is going to be the 7. The next largest is the 3. And the final one would be 0. So 8,730 is the absolute largest number that we can create using those digits. The next problem, or part B, says build the smallest number. So we want a number that's going to be teeny tiny and less than 1. So we're going to start with a decimal. And then the next smallest, well, the smallest number there is 0. Next smallest would be 3. Next smallest is 7. And the next smallest is 8. So that's how I would build those types of numbers. Now for A and B, those are the only correct answers. For part C, build a number less than 8. There's a number of different options that we can use. We want to start with, well, first of all, the number that we came up with in part B is less than 8. So that would qualify. However, that would kind of be the cheater way to go. Let's come up with a number. What digit can we start with that's going to be less than 8? So we're going to start either with the 3 or the 7, and you can pick. So I'm going to start with the 3, and then I'm going to put my decimal in there because I don't want like 30 or 37 or 38 because that would be greater than 8. It's going to be 3 point, and then I can use any order for the next 3 numbers. So it can be 078, it could be 708, it could be 807. Anything coming after that decimal is not going to increase my number to be greater than a value of 8. The other option I have is starting with the 7. I could put 7.308 or 7 point whatever. That's going to be less than 8. So just so you know, there's lots of different answers that can be true for C. Same thing with D, E, F, G. The number that's closest to 3, there's going to be one answer for, but there's going to be many different answers for I. So what I'd like you to do right now is go ahead and pause the video, fill in the rest of these, and then you can check them with a classmate or check them with me when you come back to school. But again, there's many different numbers that they could be, but you are responsible for filling in all of the rest of the answers on this page. Let's move on to the next page. Okay. Number 8 says, fill in the missing entries in the table below. You may have to find and follow a pattern. So the first line says, and I'm not going to use proper math terminology here. I'm just going to say the number as I see it. I've got 0.004, and I'm multiplying by a power of 10. When I do that, the easiest way to do it, I don't need to go grab a calculator. The easiest way to do it is by moving my decimal 1 to the right. So if I do that, I will have 0.04. I move it 1 to the right, and I've increased this number from 4 thousandths to 4 hundredths. and that's 10 times larger than 4 thousandths. So now I'm going to start with 4 hundredths, multiply it by a power of 10, and I get 4 tenths, or 0.4. And we know that that's 4 tenths. So I'm going to come over here, 0.4 times 10. Again, I'm moving that decimal 1 to the right, and I'm going to get 4. Start with 4 times 10. Hopefully right off the top of your head, you know that's going to be 40. Starting 40 times 10, 400. 400 times 10 is going to be 4,000. Now on these three, you can see that each time I'm adding a 0. There's 1 0 here, that's to the tens, to the hundreds, to the thousands. Hopefully knowing and reviewing your place value is making this part a little bit easier. And we know that when we're multiplying by a power of 10, we are moving that decimal one place over to the right, and it's increasing the number by what we call a power of 10. Now, if we're multiplying by 1/10, that's the same thing as dividing by a power of 10. We can multiply by 1/10 or divide by a power of 10, and what we're doing here is we're moving the decimal in the opposite direction. So if it's over here to the right of the 0, it's going to fall between the 8 and the 0, so it'd be 128.0. So that's the number we're going to start with, 128. My decimal's here. I'm going to move it 1 to the left, and that's going to be 12.8. Start with 12.8, multiply by 1/10, and it's going to be 1.28. 1.28 multiply by 1/10, it's going to be 128, or 128 thousandths. Starting with my 128 thousandths, making it 10 times smaller, I'm going to have 0.0128. Starting with 0.0128 times 1/10, I'll have 0.00128. Now, if I were to do it again, I'd have 0.000. Again, my decimal just keeps moving one spot over to the left. So in a multi-digit number, a digit in one place represents 10 times as much as it represents in the place to its right, and 1/10 of what it represents in the place to its left. So let's look at number 10. Explain the relationship between the two threes in the number 533,271. So 1 3 is in the thousands place. That represents 3,000. The other 3, I should probably switch colors here so that you can see that I'm switching to the other 3. The other 3 is 30,000. So we want to know the relationship between these two numbers other than they're right next to each other. So if a digit in one place represents 10 times as much as the place to its right, this digit right here in the 10,000s place is 10 times more than this digit in the thousands place. Similarly, this digit in the thousands place is 1/10 of this digit in the 10,000s place. Hopefully this is confusing only in that we are breaking it down into terms like this, okay? You probably have known this intuitively, but you've never put words to it. So how I would explain this, the 3 in the 10,000s place is 10 times bigger than the 3 in the thousands place. The opposite is also true. The 3 in the thousands place is 1/10 of the value in the 3 in the 10,000s place. Just so you're recognizing that each time you go up in your place value, say we're going from, whoops, that's not what I want. We're going from, why is everything wiggling? Just want a cursor. I'm not going to get a cursor, I don't think. Okay. Just so you recognize that each time you go up, you're going up by a multiple of 10. So 10 or ones, tens, hundreds, thousands, 10,000s, 100,000s. Each time I'm multiplying by a power of 10. And again, I think you all know this intuitively. It's just that we're breaking it down and reminding you of things. Problem 11, Daxon's candy. Jackson has a digital scale. He puts a marshmallow peep on the scale and it reads 6.2 grams. So 1 peep is 6.2 grams. How much would you expect 10 marshmallow peeps to weigh and why? Well, if I have to multiply 1 times 10 to get 10, to get the weight, I'm going to do the same thing with my 6.2. So 6.2 times 10, I'm going to move my decimal 1 to the right. I don't have to grab my calculator. I just move that over. It's going to be 62. So if I'm having 10 times the quantity, I'm going to have 10 times the weight. So I will just put that into some words because I know sometimes we have trouble putting things in words. I'm going to make sure that I'm writing small. Okay. Okay, so 1 peep weighs 6.2 grams. Multiply both the quantity and the weight by a factor of 10 to know 10 will weigh 62 grams. Okay, make this longer so that maybe it fits and you'll be able to read it. I should have had it typed out ahead of time. I apologize. All right, so now he's going to take the peeps off and he puts 10 jelly beans on the scale and it reads 12 grams. How much would you expect 1 jelly bean to weigh? So 10 beans equals 12 grams. 1 bean, how much would you expect it to weigh? I'm going to do some work over here. So 10, my decimal's here. To get to 1, I'm moving it 1 to the left. So my decimal's here, move it 1 to the left. So 1 bean is going to weigh 1.2 grams. It's going to be the same type of explanation that part A is. So whatever we do to the quantity, we also have to do to the weight, keeping things even. Okay, so Jackson takes off the jelly beans and puts on 10 cinnamon bunnies. So 10 cinnamon bunnies, we're going to call them 10 sin buns, is going to weigh 88.2 grams. Now he's saying, how much would you expect 1,000 cinnamon bunnies to weigh and why? So let's think about this. I had 10. I want it to be 1,000. Here's my decimal. How many times do I have to move it? I have to move it 2 to the right. So I need to do the same thing with my weight. Add a 0 there. So it's going to be 8,820 grams. Hopefully that's making sense to you. Okay, part D, estimate how many jelly beans equal 1 cinnamon bunny. So I know 1 jelly bean is 1.2 grams. Ten cinnamon bunnies are 88.2, so I got to move that decimal to the left. So 1 cinnamon bunny is going to weigh 8.82 grams. So it's saying estimate, so I don't have to grab my calculator and do an exact, but I want to know how many beans are going to equal 1 cinnamon bunny. So how many times am I going to have 1.2 multiplied to equal 8.82? So kind of like multiplied by what? I guess I should put that like that. So 1.2 times what equals 8.82. If I were doing an actual calculation, I would get my calculator out and divide one by the other. But instead, what I'm going to do is just guesstimate. 1.2, that's greater than 1. So if this was a whole number like a 1, I could just divide by the whole number and I'd say it takes 8. But since it's more than 1, it's going to be 7 and something, so a little bit more than 7. So I'm going to approximate it as about 7, or 7 and a little bit more, but we can't really do a little bit more of a jelly bean. Does that make sense? I hope it makes sense. I do recognize that I'm going a little bit long here, but this is also a voluntary video. This is one that we did in class. So if you weren't in class, I've created this video basically for your convenience. Okay, number 12 says if one package of cereal costs $2.46, then 10 is going to cost what? Again, we are just moving that decimal. So 10 is going to cost $24.60. Why don't you pause the video right now and do B, C, D, and E. Now keep in mind D and E, you're getting smaller, so your decimal is going to be going in the other direction. And if you need to do some scratch work over here, feel free to go ahead and do that. So pause the video, get that all filled in, and then as soon as you're done with that, come on back, check your work, and then we'll move on. Okay, so I filled it in. 10 is going to cost $246. 1,000 is going to be $2,460. 1/10 would be 0.246. However, we don't have money that goes to the third decimal place, so I'm going to say that's about 25 cents. And 1/100th of a package is going to be 0.0246, or again, I'm going to round that to about 2 cents. So let's keep moving on. I want to get through the end of this page because that's what we did in class today, and I don't know if I'm going to do it in the 3 minutes that I have remaining, but hopefully we'll get close. 10,000 is how many times bigger than 100? Remember the statement you completed on the previous page. Okay, so on the previous page we said that each time you're moving up a decimal or moving up a place, it's times 100. Okay, or I'm sorry, times 10. Oh, I can't speak anymore. So we're going up each time by a power of 10. So let's take a look at our difference between 100 and 10,000. I'm actually going to write them over here on the edge. You don't have to do this. I'm just showing you, demonstrating. So 10,000 looks like this, and 100 looks like this. So how many more zeros does 10,000 have than 100? So if I wanted to make my 100 into 10,000, I'd have to move 1, 2 decimal places and fill those in. So 2 decimal places, that's 10, 100. So every time I'm moving an additional place value, my number changes by a factor of 10. Since there are 2 additional place values, then the number that changes by a factor of 10 times 10, or we could say 10 to the second power, and we know 10 times 10, 10 to the second power equals 100. All 3 of these ways are showing all 3 show the exact same value. 10 times 10 is 10 to the second power, and that is 100. Remember when I was saying, I'm Mrs. Huntley to you guys, my kids call me Mom, my husband calls me Diana, your parents probably call me, I don't know what they call me, the teacher. So anyway, same person, different names. Same value, different names for it. Okay, so now we're going to write 110,000 as a single digit times an integer power of 10. Now don't let the directions mess with your head. It's really not that hard. When I'm trying to come up with 10,000, it's going to be 1 times 10 to some power. That's going to equal 10,000. So I just need to figure out what power of 10. How many times am I multiplying 1 times 10? So if my decimal is here on the right of the number, It's going to be 1, 2, 3, 4. So 4 powers of 10. So 1 times 10 to the 4th power is going to be 10,000. Similarly, 1 times 10, again, to some power is going to equal 100. 1, 2. That one you probably knew right off the top of your head. So I've written the powers of 10 here to determine, and now it says use the powers of 10 to determine how many times bigger 10,000 is than 100. Now, when we're trying to figure out how many times bigger one thing is than the other, we're going to use division. If it was just how much bigger, I could use subtraction, but when it says how many times bigger, I need to use division. Now again, I don't have to grab my calculator here because this is going to be easy peasy lemon squeezy. 1 divided by 1 is 1. Now we know, oops, not an equal. We know how to work with exponents because we just got done doing the unit on exponents. So when I'm dividing 10 to the 4th by 10 to the 2nd, my base is the same. I'm going to keep my base and I'm going to subtract my exponents. So how many times bigger is 10,000 than 100? It's going to be 1 times 10. 4 minus 2 is the 2nd power. 1 times 10 to the 2nd power is 100. So again, we're coming up with the same answer that we did in 13. Now, why would I make you do this twice? Because I'm showing you different ways of presenting the same problem. We are starting to learn about scientific notation, which is where everything is presented kind of in this format. A digit times a power of 10. If you know how to do it with easy numbers, numbers that you already know the answer to, it's going to be that much easier to do it with the more difficult numbers. Okay, so 15 says write each number as a single digit times an integer power of 10 to determine how many times bigger one is compared to the other. So they're going to all be 1 times 10 to some power. Okay, we just have to determine what the power is. So our decimals out here to the right of the number, how many times do I have to move it to get it to be right next to the 1? So it's going to be 1, 2, 3, 4, 5, 6. So it'll be 1 times 10 to the 6th power. 100, hopefully you know right off the top of your head, that's going to be 1 times 10 to the 2nd power. And if you notice, I purposely put them one on top of the other so I can just add my fraction bar because I'm going to be dividing again to figure out how many times bigger the first number is than the second number. So 1 divided by 1 is 1. I know I've got the same base, 10. 6 minus 2. So it'll be 1 times 10 to the 4th power. That's how many times bigger a million is than 100. Okay, the next one, part B. Why don't you go ahead and pause the video right now and see if you come up with the same answer I do. So pause the video, work out part B just like we did part A, and then come back and see how you did. Okay, so the answer is 1 times 10 to the 3rd power. Remember, if it's just 1 times 10, that has a 1 there, so I'd have to do 4 minus 1 when I'm doing the division. Now part C looks a little bit different. This is a really, really small number. We're not dealing with a really, really big number. So it's less than 1, which means I'm going to have a negative exponent. So it's still going to be 1 times 10 to some power, but my exponent's going to be negative. How negative is it going to be? Let's move it and see how many times I have to move the decimal to get it to the right of the 1. So there's 1, 2, 3, 4. Negative 4. The other number, again, 1 times 10 is your given. Everything's going to be 1 times 10. Just don't know the power yet. So here we go. 1, 2, 3, 4, 5, 6. So this one's the negative 6th power. Divide them. 1 divided by 1 is 1 times 10, negative 4 minus negative 6. Remember, when you're subtracting a negative, you add the opposite. So it'll be 1 times 10. Negative 4 plus 6 is going to be 2. So this number, 0.0001, is 100 times bigger than 0.000001. What I'd like you to do is try to do D, E, and F on your own. And then when we come back together, we can, actually, I'll put the correct answers up here and you can just make sure that you came up with the correct answer. But it's the same thing, except F, you're going to be doing 2 times 10 to some power instead of 1 times 10. You're still dividing, so go ahead and pause the video, work those out, and then come back to check your work. Okay, I'm not showing you my work, but I put the correct answers up. For D, you should have 1 times 10 to the 5th power. For E, 1 times 10 to the 3rd power. And for F, 1 times 10 to the 2nd power. Now, I will know whether or not you actually did this because you should be showing your work. If you're not showing your work, I know you just copied from me and you didn't actually try to do this problem on your own. The rest of the lesson, pages 40, 41, and 42, we are going to be doing in class. If you are not in class, you are responsible for doing it. I won't be creating a video to show you how to do it because it's all, we've already have examples on the last 2 videos of how to do it. So this should not be a problem for you. If you're having any confusion or any problems, make sure you make notes of them. Call and text me or send me an email. Otherwise, I will see you in class. Have a good night.